Good morning everyone. I am Tanushri Dharai from Civil Engineering branch. So in the last class, we derived the equation of bending up to the strain in fiber. So here you can see the strip AB length is equal to the neutral axis line from the CD. So we can say AB is equal to CD. Then after the application of moment, the AB strip is converting into A dash B dash and the line of neutral axis, that is CD, is changed into C dash D dash. Hence, due to the assumption of the bending equation, it is stated that the cross-section or the plane of the beam should be remain unchanged before bending and after bending. Hence, we can say that the neutral axis line, that is CD, is equal to C dash D dash. So it is unchanged according to the assumption. So CD is equal to C dash D dash. And we know that before the application of moment, the CD is equal to AB. So that we can say the AB is equal to C dash D dash. Hence, in place of AB, we can put C dash D dash. So here also we can put C dash D dash. Now, we have to find out the value of A dash B dash and C dash D dash. So let's see. So here, the value of A dash B dash. The A dash B dash is from this point to this point. So it is look like an arc section. So we know that in mathematical word, if the angle between two radius is theta and the value of this radius is r, then the value of r will be radius into angle in between two radius. That means r theta. So here you can see, if we will consider the A dash B dash portion, that means from here to here, the radius from the center point, that means here to here, is r plus y. How? From the center to the neutral axis line, the radius is equal to r, and from the neutral axis line to the AB small elementary section, the value is small y. Hence, the total radius we can say r plus small y. And then the theta is the angle between two radius. Hence, the A dash B dash value will be r plus y into theta. So, we can write in the place of A dash B dash r plus y into theta. Similarly, the value of C dash D dash will be this point to this point. That means the change of neutral axis into an arc section. That means this portion. So here the radius will be capital R only, and the angle between these two lines is theta. Hence, the C dash D dash value is r into theta. So we can put in the place of C dash D dash r theta. divided by C dash D dash. So here also we put r theta. Hence, by simplifying all these things, we can get r theta plus y theta minus r theta whole divided by r theta. So here r theta will be in positive and here in negative. So these two terms will be cancelled out. Hence the value will be r theta by y theta by r theta. Hence theta will be cancelled out. Hence the total value will be y by r. And strain, we know that your stress equal to force per unit area, and force per unit area, so we can say your sigma divided by capital E, that is Young's modulus, will be the value of strain. So as per the Hooke's law, we know that the capital E is the factor, that is Young's modulus, which equal to stress by strain. Hence, strain equal to stress by Young's modulus, that is sigma by capital E. Hence, we can put in the place of strain, stress by Young's modulus value. And now, we got half of the derivation part, that is sigma by E is equal to y by r, where E equal to Young's modulus. Now, the second half of the derivation part, that is from this equation, that means sigma by y is equal to E by r. From this equation, we can find out the sigma value as sigma equal to E by r into y. But we know that according to the stress formula, stress is equal to force per unit area. So delta A is the small elementary sectional area of the section AB. Hence, according to the stress is equal to force per unit area. So that we can write force equal to stress into area. So here, by putting this value, force equal to stress into area. So here we can only consider the small strip AB value. So stress multiplied by delta A, that is the force for the AB strip. Hence we can put in the place of stress value E by R into Y, that we have got in the equation 1. So by putting this value, the force value will be changed into E by R Y del A. Okay. Now, due to the momentum about neutral axis, we have to multiply the y value, that is the distance between neutral axis to the strip AB, in the both sides of the equation. Hence, it will be converted into Fy equal to E by R y square del A. Then, we know that the bending moment formula is force into perpendicular distance. Hence, here moment equal to, for the entire section of the area, we have to provide this value, that is m equal to E by R summation of the y square del A. So by this value, only this one, that means summation y square del A is equal to your I value. that is second moment of area, which is represented as capital I. Hence we can put in the place of this capital I. Hence your m value is converted into E by R into I. So now if we simplify this equation, then we can get E by R is equal to m by I. And previously we know that your E by R is equal to sigma by Y. Hence your formula by together is equal to sigma by Y is equal to E by R is equal to m by I, where m is the bending moment, R is the radius of curvature, F or sigma is the bending stress of the section, then Y is the distance of fiber to the neutral axis, I is the moment of inertia about neutral axis, and E is the Young's modulus. To remember this equation very easily, there is a short trick, that is me I, follow you, Elizabeth Rani. Me I, that means m by I, follow you, that means f by y, Elizabeth Rani, that is E by R. So today this much. We will solve some numerical based on the bending equation in the next class. Thank you.